Hello everyone, welcome welcome to another exciting time together. Here we're looking at the possible Neco exam in chemistry, that is the qualitative analysis. So um, in that analysis we were given two sorts to look at, and one of them is tagged X and the second one is tagged Y. So in the first um, one that is tagged, that has the tag of X, is known to be zinc triazocarbonate. So this is a brief analysis of how um, analysis of possible methods of pattern of of identifying the ion. So what we have here is the test, observation, and inference. What you expected to see. Now, the first part there, we're looking at the solubility test. We're looking at the solubility um, of the compound. Now, in the solubility, we add what? X plus distilled water. What we observe there is white precipitate, which is insoluble. Because it's insoluble, white precipitate insoluble, it simply means that an ion like this, sodium, potassium, and ammonia, are not likely to be there. They are not likely to be there because these three ions are known to be what? Soluble in every condition. They are very, very soluble. So in that case, since it's insoluble here in water, it means that these ions are not likely to be expected. It's insoluble, meaning that insoluble ions are present there. So in that case, another portion of that, another solid sample of the ion of the compound are dilute hydrochloric acid. Then what we notice there is an effervescent that occurred, colorless, odorless, colorless, colorless gas and odorless gas that is involved, that came out, turn lime water, milky, and also turn blue litmus paper red, meaning that the gas coming out is also acidic. I miss it up here. I miss that one out here. It means it's acidic, and we have odorless and colorless. The gas here is also colorless gas. It's colorless. Don't mind my don't mind that on the boy way that I'm trying to put it there. Is colorless. Colorless gas that is produced. Then we have the turn lime water. Lime water is nothing less but sodium and calcium hydroxide. Calcium hydroxide in solution. So it turns lime water milky, making it possible to confirm hydrogen carbonate ion or triazocarbonate ion, because carbon 4 can only come from these possible ones, can only come out from here. But we go ahead to look at the when we divide the final the residue, the final the residue of the reaction of this reaction here into two portions. The first portion there, we added dilute sodium hydroxide in drops and in excess. So what we observe there is that white precipitate soluble in excess. Then that means aluminium and zinc is likely present. Now note, lead has the same shows the same precipitate whenever sodium hydroxide is added. But for the fact we added chlorine, hydrochloric acid here, we know that lead chloride is not soluble. And we have a soluble solution here, meaning that lead is not present. That is why we are not likely to attach lead ion into this, because what we have here already is showing us that there is no lead. Because if any lead ion is present, once you add this sodium hydrochloric acid, it will just give you what? It will just give you a precipitate, white precipitate, which will dissolve when you heat it, when it's hot, and you have a precipitate back again when it's cold. So that's why we have this here. So in the second portion, we add aqueous ammonium. What we observe there is that white gelatinous precipitate soluble in excess, making it zinc, making it possible for us to confirm zinc. Now, looking at this now, one thing is sure, you know that aqueous ammonium in aqueous